Hello everyone, today we're going to talk about transpiration, a true story of removing water from plant.
Do you ever wonder on how plant takes water? What is transpiration? Transpiration is the process by which moisture is carried through plants and then changes to vapor and is released to the atmosphere. There are three regions of water pathway in transpiration, which are roots, xylem in trunk, and leaves. So, we are going to show water movement for transpiration process in these three regions, which started from root, xylem, leaves, and finally evaporated to atmosphere. This is the root of most plants where transpiration process starts. First, water is found in the spaces between the soil particles. Then, water and mineral salt enter through the cell wall and cell membrane of the root hair cells by osmosis. What is root hair? Root hair cells are outgrowth of the tips of plants' roots. They function solely to take up
water transport through xylems. A vascular tissue for a plant is flowworms and xylems. We talk about xylems. Xylem is a low resistance. Xylems consist of two types of trachea elements, which is tracheids and vessel elements. Trachea is an elongated spindle-shaped cells. It arranged in overlapping vertical fields. Water flow between the dams via pits, area with no secondary walls and thin porous primary walls. Vessel element, shorter and wider. The open end walls provide an efficient, low-resistance pathway for water movements. This contains of perforation plates forms at each end. Perforation plates forms at each end, allow stacking and on the form a larger conduit. It's called a vessel. Water movement through xylems need a less pressure than movement through a living cells. What the explanations on how water moves from the roots of the tree up to 100 meters above the ground. That is known as cohesion tension theory. This theory explains the water movements. Plant passive transport water through the xylems. Cohesion is a tendency of water molecules to bond with each other. Cohesion and adhesions create the tension within the xylems that help move water upwards. Cohesion tension theory. Cohesion between the water molecules due to hydrogen bonding pull more water molecules along. Water is constantly lost by transpiration in the leaf. Transpiration will utilize capillary actions and inherent surface tensions of water. Plant can get embolisms too. Embolisms is an air bubble formed in the xylems. Air can be pulled through the microscopic pore in the xylem cell wall. Embolism generally occur because of failure in hydrophilic conductivity, which is fluid move through the pore space or fractures. This occurs because of cool weather. Once gas bubble forms, it will expand as a gas and not resist tensile force, called cavitation.
Now, we are going to show how water lost at leaves region. First thing first, we need to know what is leaves. Leaves is usually flattened green outgrowth from the stem of a vascular plant. Leaves is really important organ for most plants. The exchange of oxygen and carbon dioxide as well as the loss of water vapor occurs through pores called stomata. What is stomata? Stomata are tiny openings or pores in plant tissues that allow for gas exchange and water loss. They are formed from two gut cells that join at their ends, forming a pore. When stomata are open, oxygen diffuses out of the leaves and water vapor leaves the plant by transpiration. Water is then drawn out of the xylem cells within the leaves to replace water loss. This induces a motive force to pull water up the xylem. How stomata can be opened? Stomata sense environmental cues like light to open. These cues start a series of reactions that cause their gut cells to fill with water. When signal received, the signal is then recognized by a receptor on the gut cell. Then, the receptor signals the H+ ATPases on gut cell's plasma membrane to start pumping proton out of gut cell. This loss of positive charge creates a negative charge in the cell. Next, potassium ions enter the gut cell through channels in the membrane. As the potassium ions accumulate in the gut cell, the solute potential is lowered. A lower solute potential attracts water to enter the cells. As water enters the gut cell, its hydrostatic pressure increases. The pressure causes the shape of gut cells to change and a pore is formed, allowing gas exchange and water loss. Other environmental cues are water, temperature, and concentration of carbon dioxide within the leaf. Stomata will open in the light and close in the dark. How stomata can be closed? If the plant lacks water, stomata will close because there will be not enough water to create pressure in the gut cells for stomatal opening. Stomata is the primary control mechanisms that plants use to reduce water loss. In conclusion, transpiration process start from root, taking water from soil, then water moved upward through the xylem, and lastly, water leaves the plant through stomata.
The factors that determine transpiration rates are relative humidity. As the relative humidity of the air surrounding the plant rises, the transpiration rate falls. It is easier for water to evaporate into drier air than into more saturated air. Wind and air movement. Increased movement of the air around a plant will result in a higher transpiration rate. This is somewhat related to the relative humidity of the air, in that as water transpires from a leaf, the water saturates the air surrounding the leaf. If there is no wind, the air around the leaf may not move very much, raising the humidity of the air around the leaf. Wind will move the air around, with the result that the more saturated air close to the leaf is replaced by drier air. Soil moisture availability. When moisture is lacking, plants can begin to senesce and transpire less water. Light. Stomata are triggered to open in the light so that CO2 is available for the light-dependent process of photosynthesis. Stomata are closed in the dark in most plants. Very low levels of light at dawn can cause stomata to open, so they can access CO2 for photosynthesis as soon as the sun hits their leaf. Stomata are more sensitive to blue light, the light predominating at sunrise. Temperature. Temperature greatly influences the magnitude of the driving force for water movement out of a plant rather than having a direct effect on stomata. As temperature increases, the water holding capacity of that air increases sharply. The amount of water does not change, just the ability of that air to hold water. Warmer air can hold more water, while cooler air holds less water. Hence, warmer air will increase the driving force for transpiration, and cooler air will decrease the driving force for transpiration. That's all from us. Thank you.